Hi, everyone. Great to have you here, and thanks for being here. My name is Agnieszka Niezgoda, and I will be talking about agents, doing agents on Azure, basically. But before I start, I wanted to ask you, just to get a sense of who you are, who of you has already coded an agent? Okay, and who of you has already coded an agent using the Azure stack? Okay. Thank you. My role at Microsoft is a technical one, but I work with customers. I work with the biggest Polish enterprises, and I help them to implement agents, but also other tools, other solutions based on Azure, and especially with focus on AI and to some extent data. I've been doing a lot of such projects, and I've observed some typical challenges, for example, that the companies are encountering. That's why I wanted to focus on that during this presentation. I think a common way of doing agents or doing LLM projects in general looks like this. So at the beginning, we have some business aspects, of course. So we need to have a good use case for agents. Then we think about the whole agentic workflow or the process that the agents will be working according to. And then we are specifying how it should work, what the termination strategy should be, how should we define the agents. And at the end, we also decide, for example, what approach we should take. So should we go no-code, low-code, or the pro-code way, right? And let me just touch upon some of them. If you have any questions, I will be happy to address them at the end. Or I think after this session, we also have a pause. We have a lunch break, so I will be happy to discuss it with you, of course. Just one or two very general slides about agents, just to understand what we are talking about here. An agent is an LLM that can answer questions, but it's an LLM that normally also has access to tools. So it can do something for you. It can find some information for you in some data repository. It can connect to the internet to search for something. It can connect to your forecasting model. It can create a record in the ERP system. So you have some input. It's normally your prompt, although that's not always the case. The agent uses some tools to produce some output that you expected to produce. So let me show you a short demo. This is an app that I've created to show how agents can automate processes. And I imagine that I'm working in bookkeeping, in accounting, and I receive a lot of invoices every day, and I have to make sense of them. So I have to check them with my ERP system if they are correct or not, and then I have to input them, record them into our ERP system. So this is, as you see, a super simple user interface. And I also created a mock-up ERP, and you see it now. So you have various invoices here. I've created it just to show what the agent can do with it. So you have different invoices here with different lines, and you can edit them here because that's what I expect my agent to do in a second. Yeah, and here you have also like purchase numbers. I will be expecting the agent to add a new invoice that just came in here. So the only thing that I will be doing here, I meaning Agnieszka, is adding this invoice and clicking start transformation or something similar. Yeah, process invoice. And afterwards, the agent takes over. It has access to the browser, and it should check everything on its own. So I'm not doing the rest. I didn't click here. I just observed what my agent was doing. It opened the browser, and it will check whether the contract associated with the invoice that I added to it reflects what is in this invoice. Basically, if the invoice makes sense in the context of the contract. So it took some data already from the ERP system, and now it is adding the invoice to my ERP. It extracted information from the invoice to add it here to the user interface of my ERP. It's quite chatty. The remark that it's adding, it's quite long. So let me just speed it up a bit. So you get the extracted data from the invoice, the information extracted from your ERP, analysis whether the rules that I defined for all my invoices were met, and you also see that a new record was created in my ERP system, actually in order to prove that the agent make a screenshot, which is here. So you see that one complete business process can be automated using computer using agents. But if we are thinking about the process of implementing such agents, then there are a few points that we should focus on, that we should keep in our heads. And I frequently come across the situation that customers would like to create agents that follow the rules very to the word, meaning they do exactly the same thing every time. And in such situations, the question frequently can be posed, should we be using the agentic approach at all? Another thing that I frequently come across is the question, yeah, but what if my agent commits an error? Agents, LLMs commit errors. We can reduce the probability, the risk that they will. However, normally some risk will always exist because it exists if we are working with humans, right? Let me show you another example, how you can reduce this risk. This is a simple translation app. It simply translates text. You give it some text, you define the languages you want to translate from and to, and you should get a final translation here. Let me speed it up again a bit. But what it does, yeah, we got our translation, but we also got a whole process behind that. So first, this translation initial was created. Then another agent took over. It reflected upon the translation. It corrected the mistakes from the first translation. And then the final translation was created in this way, right? In this way, we can improve the quality of our applications. And of course, in this case, I showed the whole process, so the 3 versions of the translation, just to show you how it works behind the curtain. But normally, when using the app, users wouldn't see that. They would just wait a few seconds longer for the whole process to run, and they would get the best possible answer. Let me show you one more thing, how you could test your apps. And I was here for the previous session, and it was very interesting. It's related also to what I will be showing now. This is just a simple app I created, and it doesn't play a role in this demo. It's only here to show you what I will be testing. So it's an app, a chatbot, that has access to Polish public authorities' documents, and it should find tax interpretations which are most similar to what I'm searching for, right? It's using the Eureka website, if you know it. So let's imagine we want to test that. In the app that I've created, I will need some information to input. I mean, which API are we hitting? Are we targeting here? So I'm showing you here that I've copied that. Then I've created a few test cases. The query, so the question that should be posed to my agents. Then the context, so the document base, the text base based on which the interpretation, the answer should be returned. And then the ground truth, so the perfect answer. In this case, I simply copied this, so it's the same, but normally it wouldn't be, right? Just to speed things up. And then in this app, I get results for groundedness. Is the response grounded in the documents that we wanted it to be grounded in? Relevance, is the response relevant? But you can also create your own metrics, your own results here. For example, GDPR, RODO. What is the risk that the response contains the data which is GDPR relevant? So, and in this way, by conducting this test automatically 100 times, 10,000 times, you can find out in what percentage of the tests the answer will contain data that you don't want it to contain, or the quality of the response will be lower than you would like it to be. And remember that you don't always have to create agents from scratch. Sometimes when using Azure, you can use agents that are already inherent, that are already incorporated into some Azure services, for example, into Azure AI Search. So there is a quite new functionality there, which is called Agentic Retrieval, and which creates agents behind the scenes for you. And they analyze the query, they find these passages, these texts which are most relevant for the query, and they return it. They merge it together and return it. We've tested it, of course, before we launched the new functionality, and the improvement that this functionality offers is really high, especially for those questions, for example, users' questions in case of chatbots and voice bots, which are a bit more complex. For example, a user asks, how much does product A costs and what are your opening times? So the classic RAG would have issues answering this question because these are like two questions actually, but this functionality makes it easier to these questions to address without creating a more complex process behind your app. Okay, let's move on. The first thing when thinking about creating an agentic process is, well, to think about the process. So how should it develop? What would be the steps? And I feel that it's good to do this thinking about the current process, the human process. Only then we can think about optimizing it. Maybe some steps aren't relevant in the automated process, for example. Maybe there's some inefficiency in the process. But if you know what the process looks like now, it's a good starting point. And frequently when talking about agentic AI, people make a distinction between workflows and real agents. Although in my opinion, we should be more careful here because there are a lot of steps between workflows, so a more deterministic process and completely autonomous agents. For example, this is a process, a diagram created in LangGraph, where you see a simple process for a cost center. So let's imagine that we have a call center, sorry, not cost center, and plenty of emails come in, and we want to first categorize them. So is it a business-oriented question or is it a technical question? We want to analyze the sentiment of the email, because if the customer, for example, is very upset, then maybe we want to forward the email to a human instead of an agent. And based on these two categorizations, you can then decide which agent, these are all agents, should take the question. Each of these agents have their own knowledge, so they have access to their own documents, which are different, for example, for commercial questions and technical questions. And they have access to different tools. For example, this one can connect to the internet, to our website, to check what we've published there, right? They can also use different models. For example, this handle general agent is probably a quite easy one. I mean, the tasks that it performs shouldn't be super complex. So we don't need a more complex and therefore more expensive model here. So when thinking about agentic processes, it's good to imagine this path. No matter how much autonomy we want to give to each of the agents. Sometimes you want to do it differently. So you want to have an agent which plays the role of a manager and which then assigns the tasks to individuals. So you don't have a stable path anymore. Instead, you want the manager to decide. And frankly, this is probably more interesting than the previous one, the previous way of doing agents. But most companies want to go this way. They want to have more control. And it also makes sense for most of the use cases to go this track. But just to show you how this could work. This is a short app that has been created to show how a manager can coordinate the teams to find you, for example, something to buy. So I asked it to find me a nice piece of clothing on Amazon.com, and it starts coordinating the orchestrator with web server and with another agent, which is also here beneath that. And the one clicks on Amazon.com and the different subpages, and orchestrator says, yeah, that's the correct way of doing that, or no, go back. And at the end, they come to the conclusion, yeah, we've performed the tasks. And here you have your code, right? So we don't have a clear path. We don't define it at the beginning. So they can behave differently if they encounter some problem. For example, if Amazon.com asks the user to log in or something similar, if Amazon.com changes the layout, etc. On the other hand, it consumes more tokens and normally also more time because they have to think about the whole process. Okay, let's go on. So when it comes to Microsoft Stack, there are several good ways of doing agents. We have Copilots. Copilots are tools that you simply use. You don't have to code anything. Normally, you can customize it a bit, but not too much. Then you have Copilot Studio, which is our low-code solution. And then we have Azure AI. That's what I've been specializing in. And this presentation also focuses on. But remember that the previous ones also exist. So for example, if it comes to a researcher, you want to produce a 20-page long research paper on something. You can use something that already exists. It's called Microsoft 365 Copilot Researcher. You give it a topic, it researches for 5 minutes, and it returns an answer. Or you could go the low-code Copilot Studio way, right? Or the way I did it here, I created an app to research the stock market for me. So I created around 5 different agents. One of them analyzes the momentum, the current situation of the stock of some company. The other analyzes the value, meaning price to equity, etc. And they all connect then and produce a report for me to decide whether I want to invest in some company or not really. So depending on what you are looking for, what results you want to receive, you can select one of the two UIs, no code, low code, or pro code. Or here, one of the most typical ideas companies have if they want to implement agents is to use them for the chat with your data purpose. So every company would like to have a place where they want to ask questions like, why did our sales decrease last month? And get a reasonable answer. And it's possible to do it so many ways. For example, here, this is Microsoft Fabric. There is a functionality called Data Agent there. You can use it directly within Fabric, but I also created a user interface because the functionality is accessible via an API. So I created this app, and I can ask it questions and receive answer, which is based on our data. So to sum up this part a bit, it frequently makes sense to think about big organizations as two-tier organizations. On the one hand, it makes sense to give people some good productivity tool. for them to be able to translate things quickly, to create marketing campaigns, some training materials, etc. And frequently, this role is played by Microsoft 365 Copilot. But on the other hand, frequently we see these central IT-led efforts to implement solutions which are relevant from the point of view of the whole organization, or at least a few teams, right? And then we are going the pro-code way, because low code has all the advantages and disadvantages related to it. Meaning Copilot Studio is great for very standard use cases, but if you want to implement something very customizable, well, that's simply not the solution for that, right? Go the Azure way. Yeah, precisely. Microsoft Foundry, the previous name Azure Foundry, is a great solution when it comes to especially securing the governability of your solution, the testability, observability of your solution. It has been developing a lot in the last 2 years, and it has been given more and more functionalities linked to testing, tracing, and similar. Let me show you what it looks like. So that's the Foundry, and here you have the model catalog. Currently, we have over 11,000 different models which are available here. So you can, of course, use the classic models, GPT, GPT-5, GPT-5.2, but you also have access to Claude, for example, to the newest Claude models. You have also access to Bielik and open source models. That's not an issue. So on the one hand, you have all the admin here, all the models, and you can see how much capacity you still can use. On the other hand, you can also test it here. Let's speed it up a bit again. You can, of course, test also the production of videos and of images. Oh. You can fine-tune your models here. This was also mentioned in several other sessions. So when it comes to fine-tuning, there are two challenges mostly. Lack of good data, or how to create a good quality data, and compute power. It normally takes a lot of compute power. And here you can do it in this managed way, so the infrastructure is created for you and you just pay for the number of tokens that you trained on. Yeah, tracing, monitoring, just very shortly. And of course, you have the content filters here. That's important. So you can decide what is blocked, what the prompts that are sent to your model cannot contain, and how to react to that, and what the answers also shouldn't contain. When it comes to these safety aspects, Foundry does offer a lot. So you have a lot of quality evaluators, but also evaluators, for example, related to agents. Testing agents has always been complex because, well, even if you define the process well, it can go so many different ways, and it's difficult to find out whether the path that the test went, for example, was correct or not. But in the meantime, we already have some good ideas how to do that. And one is, for example, tool call accuracy. So where the correct tools used in this specific flow, in this specific task, right? A cool thing about Microsoft Foundry, one that I personally love, is that you can host your LangGraph models, your LangGraph apps there. So I'm a huge fan of LangGraph. I create a lot of apps in that, and you don't have to create them any specific way in order to host them on Azure. You just create them and then host them. We have scripts for that, and it gives you several things. The first thing is the quick testing. So it's here, you see I've tested it on Foundry. Then it gives you governance and observability. tracing, you can conduct all the tests that I've just mentioned. And then you can integrate your LangGraph and Microsoft Agent Framework agents very easily with the rest of Microsoft stack. So for example, with Microsoft 365 Copilot, what I'm showing here, but also Teams. It's really a few clicks if you have your admin rights, and it should work for your whole organization or just for several groups, for example, from your organization. Okay, I see that we have to finish in a second, so let me just share with you a few slides very quickly. This is a typical road to your agents on Azure. So at the center, you have your Microsoft Foundry, governability, observability, but you also have a lot of other Azure services. And then one important service to think about if you are launching an enterprise-grade solution is API management, which plays a role of a load balancer, where you can create policies to restrict access, for example, to some of your endpoints. Okay, let me skip that then. Okay, so I think I have to be done, so I'm done, and thank you very much. And if you have any questions, I will be happy to address them.
Yeah, so first of all, you did like 5 demos in one presentation. That has to be some kind of a record. And so thank you for that. It was great. And getting to my question, in one of your demos, you mentioned that the agent is very chatty. And from my experience, if you have a lot of output, a lot of content from an agent, many times people just don't go through it, don't read it fully, and internet even have a name for it, work slop, which is like a lot of content, but not a lot of value within a content. What would be your approach to ensure the most value in the content of the output of the agent?
It depends on the context, right? In this case, I simply didn't ask it to limit its response to, for example, I don't know, 20 tokens or characters. So it didn't know what rules it should stick to. But if I did, and also I could have changed also the max tokens parameter, then it would have been briefer in its answer. So I don't see this as problematic. And if I had done that and the agent still wouldn't be obedient enough, then I would simply create an additional step, like a tester, a checker, and it would check whether the output from the first agent can be made better.
Any more questions?
Thank you for the presentation. I really liked it. I wanted to ask you about what's more difficult from your perspective, like building an agent or building the knowledge for the agent. Like you showed an example of an agent like researching the database of tax rulings. And well, this Eureka system, it's mostly plain text. So I wonder like how much engineering was needed on your side to get this knowledge useful for the agent, like building some knowledge graph or something like that. And what's usually from your experience is harder and requires more time?
I think the quality of data is frequently a challenge when it comes to enterprise-grade projects. At the same time, frequently we can start with, for example, just part of the whole data repository that we want to have in our solution and go from here. And what I really love is that AI frequently helps in cleaning up the data, right? So for example, in this case of Eureka, the input were PDFs. So yeah, it's text, but it's not just text. And the PDFs had to be read and some information had to be extracted. And there are several ways to do that. You could use document intelligence, which is a good tool for that. You can also create your own model in order to extract just the very info that you need. But you could also leverage LLMs for that. And And I think this data preparation step is extremely important. So we have to think about which information will be needed by the agent. Frequently, it's even information that is not given to you like directly in your documents, right? For example, I've done a lot of projects with banks. And sometimes our customers want to have a search machine for all the documentation, so all the loans, credits, etc. And we should always add information whether the document is valid or not valid anymore, or the valid from the valid to, but still customers, if they search through this information, through these documents, want to have access also to this documentation which is not valid anymore. For example, somebody took a mortgage 20 years ago, so the information, the document is not valid anymore because no new customers are offered the same mortgage, but old customers should have access to it. So it adds a lot of complexity and it requires a lot of planning. Yeah, I agree with you.
So I guess we can thank you again. And well, one more question. Sorry. I didn't see you. Sorry.
Thank you so much. Oh, yeah. Thank you so much. Yeah, so my question is, how do you go about making decisions about how many agents to use? Because for one of your use cases, you used 5 agents that each had individual tasks, when it would also be possible to have one agent that has access to all of those tools. So I was wondering, what are you thinking about when making those decisions for how many agents to use?
Normally, you should strive for as few agents as possible, but not fewer. Meaning that if you think about having just one agent that does 3 different things, then it's not the best idea. It will become confused and it won't work that well. So I would stick to one agent, means one role. We should also give it some examples. So a few shot approach my colleague before talked about. It's better to have one agent too many than one agent too few. Also, I remember these projects like 2 years ago when this trend for LLMs just started. And for example, the definition of every agent, which we didn't call agent back then yet, was very long. So it was like sometimes 3,000 tokens just to define how an agent should behave, right? And currently we tend more to go for simplicity. And if this one huge agent can be divided into 3 different ones with very clear task and role, it's even better. The probability that the result will be what we are searching for is much higher than before.
I guess that's it. We're heading into the lunch break at 1:30. We're coming back. So thank you.